Hello again, it's me. You're getting tired of hearing that. All right, let's talk about quantities some more. Okay, so we talked about formula weights, we talked about molecular weights, we talked about what a mole is. There is a concept or a skill that is using something called empirical formula. Now, the empirical formula is the smallest ratio. Okay, that doesn't mean it will exist, but the smallest ratio of either atoms or ions in a formula unit. Now, we already do that for ionic compounds, but we don't for molecular compounds. But if you take a sample and you run it through an analytical machine, it might not tell you, hey, there's two carbons for every, eight hydrogens. It will tell you a percent or it will tell you a ratio. And those ratios can be interpreted to work backwards and tell us the chemical formula. So it's always written with the smallest possible integer, basically the subscripts in an atom, or the subscripts on the atom. It does not always correspond to a molecule, but it does correspond to the ratio that they occur together. And then just here's some examples. So for instance, an empirical formula is CH. Now, if you were trying to do the Lewis structure, that doesn't exist. But if you multiply it by full integers, you could get C2H2 or C6H6. So the ratio of the carbons and the hydrogens to each other are 1 to 1. Well, the empirical formula could also be CH2, CH3, okay, so forth and so on, CH4. So why is it powerful? Well, when we start getting, more than just two atoms, it would be nice to know their relationship to each other. And so if you'll notice, this is now just combining oxygen with my carbons and then nitrogens. So we're going to determine what is the actual formula. And then there's two ways to do that. One is using the mass and one is using the composition. And so using mass, the question would be phrased with something like this. All right, we sent 10 grams of an unknown sample off to a lab and they did elemental analysis and they said that 6.21 grams of it was carbon, 1.04 grams was hydrogen, and 2.76 grams was oxygen. Okay, what is the empirical formula? Now, I do know that atoms weigh differently from each other. Okay, chemists never compare grams of things. We always compare moles of things because that means they have the same number in there. So 6.21 grams of carbon. I wrote right over the top of it, 1.04 grams of hydrogen and 2.76 grams of oxygen. And I'm not going to have enough room here, so I'm going to try and remember that and go over 6.21, 1.04. So we have 6.21 grams. See, still can't remember. Jumping back to it here. Sorry, I'm jumping all over. You're like, whoa, what are you doing?